So you're standing in a massive, echoing airport terminal, right? It's basically an acoustic nightmare. Yet somehow, when the gate change announcement comes on, you hear every single word perfectly clearly. How does that happen? Today, we are doing a deep dive into the invisible infrastructure making that possible. Specifically, the QSC AD-C6T-HC 6.5-inch two-way passive ceiling mount loudspeakers.
That's a mouthful of a name, but yeah.
It really is. But our mission today is to decode these dense audio specs to understand, what justifies a $1,070 price tag for a pair of weight ceiling speakers. Okay, let's unpack this.
Yeah.
Why can't we just buy some standard speakers, bolt them to the lobby ceiling, and crank up the volume?
Well, simply increasing the volume in a massive space is honestly the absolute worst thing you can do. The sound waves just bounce off the floors, the glass, the walls.
Creating a total chaotic mess of echoes, right?
Exactly. You don't need more volume everywhere. You need incredibly tight, controlled coverage. So these specific QSC speakers are built with a 75-degree conical coverage pattern.
Which is pretty narrow.
It is. And when you combine that focus direction with their ability to hit a massive 116 decibel peak sound pressure level, or SPL, you get highly directed, powerful audio cutting straight down to the floor.
I picture kind of like trying to light up a foggy room. If you just hang a bare light bulb from the ceiling, the light just scatters everywhere, hits the fog, and completely washes out the room. Like you can't see anything clearly.
Right. It's just a diffuse mess.
Yeah. But a tightly focused spotlight that cuts a clean column right through that fog all the way down to the floor. So that 75-degree coverage pattern is essentially our audio spotlight.
That's a perfect analogy. Now let's move from where that spotlight points to how it actually sounds. Inside the unit, there's a 6.5-inch paper woofer handling the low notes and a 1.4-inch dome compression driver handling the highs.
Okay.
And they use a coaxial design, meaning the tweeter is placed directly inside the center of the woofer, so they share the exact same central axis.
Wait, but why does that specific placement matter? Like, does sharing an axis actually change what we hear?
Oh, it completely changes it. I mean, if high and low pitches originate from different spots on a speaker enclosure, they hit your ear at slightly different times.
Which creates that kind of smeared, muddy sound you get in bad venues.
Precisely. By putting them on the exact same axis, all those sound waves originate from the identical point. They hit your ear simultaneously, which keeps the audio perfectly phase accurate.
Meaning you get this crystal clear audio across the whole frequency range, from 45 hertz all the way up to 20 kilohertz.
Right. But getting that acoustic performance into a commercial ceiling takes some really serious engineering. I mean, installers are usually 30 feet up on a scissor lift, putting in dozens or even hundreds of these at a time.
Yeah, that sounds like a nightmare.
It can be.
Oh.
So to make it safe and fast, QSC uses a blind mount system with double-stepped dog ear clamps.
So the installer just pushes the speaker into the ceiling cutout, and the clamps automatically lock it in from below. Like, there's no need to crawl around above the ceiling.
Yeah, exactly. They also include 70 and 100-volt transformer taps, because if you tried to wire, say, 50 standard home speakers to one amplifier, you'd blow the amp immediately.
Oh, wow. Yeah.
So these taps allow an installer to daisy-chain dozens of these speakers together safely, which makes massive commercial systems easily scalable.
Okay, let me push back here for a second. Let's be real. You can put the fanciest physical hardware in the ceiling with perfect phase accuracy and easy mounting and all that. But an atrium is still a giant glass echo chamber. I mean, hardware alone can't fix bad room acoustics, can it?
No, it really can't, and that's where the digital side of this ecosystem has to step in. QSC solves that software side with something they call intrinsic correction voicings through their QSYS platform.
So the software is actively optimizing the sound to fit the physical room.
Yes. It applies specific tuning to ensure the tonal characteristics stay remarkably consistent across their entire acoustic design series.
Oh, I see. So an architect could put these high-power narrow speakers in a massive lobby and then smaller, low-profile speakers down a quiet hallway. And the software syncs everything so the actual tone of the music or the voice doesn't weirdly shift or drop in quality as you walk from one zone to the next.
That's the real magic here. Whether you are outfitting a commercial space yourself or you just love understanding how things work, it's really a perfect example of how high-end audio uses physical engineering and digital processing to overcome the physical nightmare of massive rooms.
It definitely makes you appreciate the invisible infrastructure all around us, which I think leaves you with something to ponder today. The next time you are in a chaotic, crowded airport terminal, but you can perfectly understand a gate change announcement over the noise, look up. How much of our psychological calm in public spaces is secretly engineered by highly focused, phase-accurate technology hidden right above our heads?